All right, so today we are going to talk about the reciprocal and quotient identities. We want to express everything in terms of sine and cosine. We have our song, which we just played before. S goes with C. Secant theta equals 1 over cosine, and we did talk about that in an earlier lesson. C goes with S. Cosecant theta is the reciprocal of sine. Tan is sine over cos. And cotan starts with cos. So we're going to be using these for all of the questions that we're going to be doing in this lesson, and then we're also going to be using it later on as well. I'm just going to move for a moment. So either take a picture of this or take a screenshot or just write it down the old-fashioned way, but make sure you have this to refer to as we're going through. So I want to express everything in terms of sine and cosine. That's the understanding that you need to have. I want everything to be in terms of sine and cosine. So cosine is already in terms of sine or cosine, so I'm not going to change cosine. Cosecant, well, cosecant is 1 over sine. So I'm going to replace that with 1 over sine. Now, if anything cancels, cancel it. In this case, nothing is going to cancel. So on top, I have cosine theta times 1, which is cosine theta. And on bottom, I have 1 times sine theta, which is sine theta. Now, we want to express our answer in terms of one trig function. So I have cosine over sine. Well, what's cosine over sine equivalent to? What's cosine over sine equivalent to? Cosine over sine is equivalent to cotan. My answer is cotan. So I express everything in terms of sine and cosine. I cancel if possible. Nothing canceled here. I kind of multiply straight across. I ended up with cosine over sine, and cosine over sine is cotan. Any questions so far? Number 2, tan theta, cotan theta. So I want to express everything in terms of sine and cosine. So tangent is sine over cosine. Cotangent is cosine over sine. Now, I can cancel anything on top with anything on bottom as long as it's the same. They don't have to be in the same fraction. So the sines are going to cancel. The cosines are going to cancel. Nothing's left, so the answer is 1. Any questions on that? All right, number 3. Cotan theta, secant theta. I want you to try step 1 on your own. Replace cotangent with what it's equivalent to. Replace secant with what it's equivalent to. I'm going to give you about 15 seconds to do that. And again, refer to this to know what to replace it with. Okay, cotan is cosine theta over sine theta. Secant is 1 over cosine. Any questions so far? Now, I want to cancel out. If there's anything the same on both top and bottom, cosines are going to cancel. I'm left with 1 over sine. I want to express my answer as a single trig function. So 1 over sine is equivalent to cosecant. And that's my answer. Questions? Why don't you try number 4 on your own? Replace all the trig functions, express them all in terms of sine or cosine. If it is sine or cosine, leave it as sine or cosine. But if it's one of the other 4, replace it with the appropriate identity. Cancel out whatever's the same on top and bottom. Clean it up. So why don't you take a moment and try number 4 on your own. And if you finish 4, feel free to move on to 5, 6. If you work faster than some other students, take a couple minutes right now. Try to get through at least 4. All right, let's go over number 4. Secant 1 over cosine, cosecant 1 over sine. Cosine is cosine. And you can put it over 1 if that's a little bit easier for you. Cancel out whatever you have on both top and bottom. Cosine and cosine cancel. I'm left with 1 over sine, and 1 over sine is equivalent to cosecant. Express everything in terms of sine and cosine. Cancel stuff out. Clean it up. Let me kind of put that into the notes somewhere. So for reciprocal quotient identities, 1, express everything in terms of sine and cos. Cancel out if you have anything on both top and bottom. Clean it up and replace into a single trig function. All right, there's one more little twist that we're going to see. Number 7. Cosine of theta divided by secant of theta. So, same thing. I'm going to express everything in terms of sine or cosine. So secant is 1 over cosine. So now, here's the big question. Do you remember how to divide fractions? We did it earlier this year. You did it back in 7th grade and pretty much every year in between. To divide fractions, we multiply by the reciprocal. So it's cosine theta over 1 times, and then we flip the fraction that we're dividing by. Now, cosine of theta times cosine of theta is cosine squared theta. For whatever reason, you're like, well, Mr. Schlansky, why isn't it cosine of theta squared? It is. We just write it with the squared in front of the theta. I do not have a good reason why, but these mean the same thing. We usually denote it that way. The answer would be cosine squared theta. When you're dividing by a fraction, keep change flip, multiply by the reciprocal. Why don't you try number 8 on your own? you're going to have to keep change flip because you're going to end up dividing by a fraction. Again, the first step is to rewrite everything in terms of sine and cosine. Cosecant is 1 over sine. Cotangent is cosine over sine. When I divide by a fraction, I multiply by the reciprocal. I keep change flip. So 1 over sine theta times sine theta over cosine theta. Sine thetas cancel. I'm left with 1 over cosine, and 1 over cosine is secant. Any questions on that? That's all I got for you with this lesson. So I'm going to give you about 5, 6, 7 minutes or so to practice, and then we're going to move on to the next lesson, which is a different type of identity, Pythagorean identity. So again, to sum up, for reciprocal and quotient identities, you want to express everything in terms of sine and cosine using these identities. S goes with C, C goes with S, tan is sine over cos, and cotan starts with cos. Then you're going to cancel out anything you have on both top and bottom. If there's a sine on top and a sine on bottom, for example, cancel them out. Then you kind of clean it up, you multiply straight across, and then you need to replace it back into a single trig function. Again, your classwork/homework is to finish this assignment, and I hope you have a productive next few minutes.